Can we revive a machine that's dead on arrival? Let's find out. Today we have a Husqvarna Viking One Plus, and this machine is having problems where they took it to their local repair shop and they said it needs a new motherboard. You can't get them anymore, so it is broken. I have not tried testing this machine at all, so we might actually try and test this machine out a little bit before we get into our favorite part of the video. Well, there are no signs of life in this machine. Alright, we have no signs of life. So without any further ado, let's get to... Wait a minute. This is an emergency. This is a Husqvarna Viking emergency. Okay, that hurt a little bit, but we got our tools, so it's time, without any further ado, to get to the teardown. Alright, now that we've got this machine taken apart for the most part, I want to concentrate on the power supply here, but I also need to clean the machine because it's pretty dirty. There's a lot of fuzz in the bottom of it, so we're going to blow this out, we're going to lubricate the machine and all that, and then we'll get into looking at the power supply, seeing if the power supply is working right, and then maybe looking at the machine as well, depending on what we find there. Alright, we just cleaned the machine and oiled and everything, and now we're getting to the part where we're troubleshooting. So there were no signs of life on this machine. And before I go to the main board on the machine, I want to check the power supply to make sure the board is getting the power that it needs. Because we saw absolutely nothing on this machine. So what I've done here, I don't know what voltages I'm looking for, but I know that I should see somewhere around maybe 15 volts, maybe a 5 volts, or maybe it's 25, but anywhere, somewhere around there, should see some voltages that are steady, that makes sense to power a machine. And this power supply, so I am about to plug it in and take voltage checks on it while it's plugged in. Just know that you have to be very safe when you do things like this and not touch any of the electronic components with your fingers, with your hands, because there could be a live voltage there that could kill you. So be very careful. Don't try what I do unless you've been trained on how to operate on stuff like this. So we are plugged in. I'm not sure which side is ground. I put this on the left, and I'm hoping that that's the ground. So on this machine, when you press the on button, it's a mechanical connection that operates this little guy right here. So I think I need to push this in while I do checks, which is why I had my ground. And we're going to try and go across some of these pins and see what we get. We're going DC first, and then we can try AC later. So that's 2.4 negative, 2.5 positive. Alright, I'm not getting anything that looks good, so let's let go of this and see what we get. I'm not really seeing much. Looks like it'll run a sewing machine, so AC volts, that's weird. I'm getting 5 volts AC from the air. We have seen nothing of consequence. There's no voltage above 10 volts AC or DC using the left and the right um, pins as a ground, and using that with that pushed in and that released. So we're going to open this up and see what we find inside. Again, there could be voltage in here even when it's unplugged, so always be mindful of these things before we go into a power supply. Well, that could be a problem. That looks to be right where the power comes into the power supply. Let's get a closer look. How do you come out of there? We are about to delve into the unknown here. It appears, and this is the first time I've opened one of these power supplies like this, it appears that it's been potted. So what that means is that this, the transformer, so if you can see those coils of wire, that's the heavy part on this thing. This whole area is filled up with transformer. And what they did was they put this board in here and then they squirted in epoxy. This is solid and it's attached to the board. So this part is not going anywhere because it's completely encapsulated in hard glue, epoxy. And so we're not getting this off unless we peel the plastic off the outside of that, and that's not going to get us anywhere. So what we can do is see if we can desolder the connections going to that transformer and then pull the board off. So that's what we're going to try next. Like I said, we're delving into the unknown. This is something I'm not sure that many people would do. And maybe when we're done, we will wish that we hadn't done this as well, but we'll see. We'll give it a try. While the soldering iron and everything is heating up before we get into this power supply here, check it out. We got these shirts on sewingmachinerepairguy.com, and then also when we were putting this machine, or taking this machine apart, you'll notice that I was using one of these little pry tools. So this is one of my plastic pry tools. So I sell a set of 4 of these, and this is the one I used to try and get this little part up, and then I found out it was attached pretty good. Okay, you ready for the big reveal? Because I think we got it loose. It looks like it's coming up. The switch might be catching. Yep, there we go. Here's the big reveal. What do we have? Yeah, we got a big old burn spot right there. I'm definitely going to replace this. These are the things that smoke in almost every power supply if they have them, these reefa caps. But we'll check everything else on this and see how we're looking. And then if you were wondering what I was talking about with the potted, see how this is all epoxied in here? And that just, it helps on high voltage systems with the insulation. Also helps this not to break if you drop it. We'll check these coils and make sure they're good. If the transformer is bad, we're done, because we can't get a replacement for this unless we look on the secondary market in like eBay or whatever. Alright, we've got 0.5 ohms there, that's good. We'll check this coil. I'm assuming that these two go together as a coil. 0.5 ohms there. Probably the primary, so 0.56. I don't know what this is, maybe a half. Yeah, I don't know what that middle one is. Is it connected to anything? It's not connected to anything. This middle one, in fact, when I was desoldering it, the little pad just came off. And neither side of the board has that pad connected to anything. So from what I can tell, we got a primary and 2 secondaries on this transformer. You can tell the primary because where the main power comes in. So the main power comes in through here, follows, you got these two, what are these? Fuses? And then they go to, one goes to this side of that transformer, and then the other one goes over here and then to the other side of the transformer. So this is the primary of the transformer, and then your secondary, you have 2 secondaries, so that's going to give you 2 different voltages for the machine to operate on. We got a lot of checking to do on this board. So I'm checking this fuse, and it looks like it's bad, but then if I kind of move these a little bit, you'll see that we end up getting a very low resistance, less than 1 ohm. So this fuse is good, it's just got tarnish on it. So I got to be careful when I'm looking at my readings and make sure that we're good. So we're good there. We're good there. So these fuses didn't blow when we had a gigantic fireball in there. Alright, I want to read across these. I don't know if these are some sort of protective devices. They could be MOVs or they could be something else, but they're reading about 4 ohms each. I'm going to say that's good. We got the switch. This is a switch that actually turns on the thing. So this switch, and if I push on it, which side is the side? There we go. If I push on the switch, I should get a difference. Oop, I gotta hold it in. Okay. Oh, I see. When you push on the switch, it turns off. So this thing should be on when the switch is not pressed. Interesting. Okay. So we said we're going to remove this anyway. So that's one thing we're going to do. So far everything I'm checking on here is looking good, except for this guy right here. So the connector here looks fine. I think what we had was bad solder joint right there. And when your solder gets bad, you get high resistance, so you get a lot of heat buildup from that, and then it melts more of the solder out of the way, so then you get more heat, and it just kind of runs away like that, and then creates this situation. And because your current flow was right here, and all that heat was right here, it wasn't actually going through the machine. So none of the protective devices on the machine blew. That's crazy. Oh, these are inductors. Okay, this is going to be a delicate part. So we're going to slowly put this on and try to line up all the pins with these little tiny connectors. I'm sure it'll be easy, right? Oh, apparently it was. Looks like we got a good connection. We're going to see when we run the machine and see if this thing blows up again. So this time when we turn it on, we're going to check voltages here where I can see the traces and kind of figure out what's what. Which means it's especially dangerous this time, because as soon as I plug that in, it's going to be energized and it could decide to blow up on me. I do have a switch over here to the right that you can't see where I can turn off the power to this from a distance, and that's what we're going to do. So I'll plug it into here while we do not have any power to it. And so here we go. We're going to plug it in and see if anything blows up. Doesn't appear to have blown up yet. Do we have power to the primary on the transformer? Yep, 122 volts. That's good. What do we have here on the secondary on this side? So that looks like about 30 volts. So 29. Yep. On that side. Now we're checking AC because this is from the transformer. So we got 13 volts on this side. So it might end up being around 30 and 15. So now we want to check our DC voltage down here. I think we were referenced to the middle, weren't we? We'll see. So 33 volts DC on that side. And then I don't know which ones. Let's try this one. 6 volts DC. 6 volts DC. Nothing. Nothing. Negative 18. All right. We have signs of life, so that's a good thing. We won't know if this is going to burn up again until we're actually using the machine and drawing a lot of current through there. And I did remove the reefa capacitor. These are no longer required to be on power supplies, and I don't have an exact replacement for this one, so we're just going to leave it out, and that's okay. So we're going to put this back together. We're going to put it in the machine and see what we get. Well, are we ready to turn this on and see if it does anything? I think I'm ready. I did kind of forget that the +1 has a totally different foot pedal, so I told them not to send their foot pedal when they brought me this machine. That was my mistake. I should have told them to bring it. They didn't, so I don't have the foot pedal for this machine, but you can do that up here, I believe. We're going to try. All right, you ready? I'm kind of nervous. I hope this works, but I also hope that it's not going to burn up on me, so. All right. Ooh! Yes! Okay, we got signs of life. That's good. I mean, everything looks really good here. This display looks really good. It went through its calibrations. These different buttons are working. Oh man, that's awesome. A1, A2, oh yeah, it's working. It's working. Okay. So I should be able to run stop. Is that what this does? Or is that this? How do I run stop? Look at that. It's working. It's working. All right. We made something work for the foot pedal. All right, let's give it a try. We got it together enough to test. I want to run this a little bit and kind of go through the different patterns that it will do, because I want to run this motor and get this thing. Basically, I want to see if this if it's going to burn up again. So I want to run the motor and actually get it to work quite a bit. Okay, that's looking good, and it's very smooth too. It's a very smooth machine. All right, let's try our waffle stitch. I don't know if that's what it's called, but that's what I'm calling it. So here we have another machine that was DOA, dead on arrival, completely nothing worked. It was brought to a shop and the shop said, needs a new board, they don't sell them, we can't fix it. And there's no fault on their part, is that most people don't do component repair. Most people shouldn't do component repair, and that's something that I do. So we were able to get this machine back up and running. It did have a catastrophe go on inside there, but we fixed it now. We've got a nice thick gauge wire in there to complete that circuit. All the safeties are still in place, and this machine is good to go to work another day. I've still got some other work to do on it. We're going to do some more cleaning on the outside of the machine and make sure that everything on the inside and the back is good. But as far as the video goes, thanks for watching.